Welcome to the project demonstration of human posture recognition and imitation by using Raspberry Pi 4. So here we are going to identify the human postures based on the Pi camera, and also Pi camera will capture the images and Raspberry Pi will extract the person position, and also we are going to find the key points. So here we are getting the key points from the TensorFlow algorithm that is based on the CNN, that's convolutional neural network. And the key points are like coming to the right hand side 6, 8, 10. Elbow is going to be the main shoulder is 6 and elbow 8 and wrist is 10 for the right hand. Left hand side 5, 7, 9 and a waist 11, 12. So these are the main key points. I'm repeating that: 6, 8, 10 for the right hand side, and 5, 7, 9 left hand side, and 11, 12 for the wrist bases. So based on the distance between these key points, a Raspberry Pi will take a decision to control this humanoid robot arm. So here we are going to control this up and down and forward, backward with help of this servo motor, up and down with help of this servo motor. So when we lift the left hand, automatically the system will lift the left hand of this particular robot. So here we are going to control these servo motors with help of our Raspberry Pi 4 and Arduino Uno board. So the system will give the commands to the Arduino Uno, and Arduino Uno will control these 4 servo motors. So here the 4 servo motors interface rates 5, 6 and 9, 10 pins of your Uno board directly, because these pins are the hardware PWM pins, and we are sending commands from the Raspberry Pi 4 to Arduino Uno with help of 0 and 1 pin directly connected to the Raspberry Pi at 14 and 15th pins. And we place one more LED indication here. So when we switch on this kit, it start booting. After successful booting, this light will be on and off 2 times. After that, whenever the human presence detected in front of this Pi camera, the light is in keep on position, and the imitations will be given to the Arduino Uno with help of like as we discussed the TensorFlow algorithm. And here this is the breadboard to distribute the 6 volts power supply to the servo motors. So here we are providing the power supply with the 2 adapters. One adapter, this white adapter, is for the power supply for Raspberry Pi 4 and Arduino Uno, and this 9 volt adapter, this black one is a 9 volt adapter. So we need 6 volts power supply for the servo motors. For that purpose we are using LM2596 buck converter as a regulator which can handle up to 3 amps of current. So from here to the breadboard, and here we are distributing, we can see that we are distributing the 6 volts power supply to the servo motors, and servo motors are connected through this cable to the humanoid robot. So let us see the demonstration. Give the power supply to this adapter, and the next power supply adapter to the servo motors. So on initial booting, the system will on and off 2 times, that particular LED, and that LED is connected at the 4th pin of our Pi 4. Right. So now I am in front of the camera. The light is in on position. So I am lifting my right hand. So as I hold the camera, that's why it's lifting the left hand also. Same. So let us see demonstration from the back side of the camera. Right. So now let us see. So maximum of delay is going to be the 500 to 700 milliseconds. That's it.